Hello guys, welcome back to our Python course. So today we are going to learn about one of the most important data types in Python, that is list. Almost every Python program uses list because they help us store multiple values in a single variable. So by the end of this class, you will learn what is a list, how to create a list, how to access items in the list, indexing and slicing, common list methods, looping through list, and list comprehension. So let's start. Introduction to list. So first, let us understand what a list is. A list is a collection of multiple items stored inside one variable. A list is a collection of multiple items that are stored inside only one variable. So it can store numbers, strings, booleans, and even other lists. Unlike variables that store only one value, a list can store many values together. Lists are ordered, mutable, and allow duplicate values and can contain different data types. So, for example, here we are having my list equal to item 1, item 2, item 3. So here, instead of creating three separate variables, we are all storing it in the one variable, which is my list. So think of a shopping basket. Instead of carrying one fruit at a time, you keep everything inside one basket. So a Python list works in the same way. Characteristics of list. Ordered. Items stay in the order in which we add them. The items are stayed in the order in which we are add them. So for example, for this video, I'm going to use VS Code, but not the online compiler. You guys can go through the code in the online compiler if you wish to. So this is the VS Code. So first one is ordered, right? For example, if I'm having a list called fruits, fruits equal to list of apple, banana, and cherry. So if I print the fruit, the order should be the same. See, the output is apple, banana, and cherry. Okay, and next one is mutable. Mutable means we can change the list after creating it. We can add items, remove items, or update items. For example, in this list, I can add items in the existed list. For example, fruits dot append of orange, and we can print it. Before appending of orange, the list containing apple, banana, and cherry, and after appending of orange, the list contains orange too, in which we are added a new element to the existing list, which is known as the mutable. And next, allows duplicates. The same value can appear multiple times. For example, instead of banana, if I take apple, it allow duplicates. It is printing apple multiple times. So this is perfectly valid in the list. Next one is heterogeneous. A list can store different types of data together. For example, in this list only, if I take different data types like 101, this is an integer, 1.25, this is a floating, and apple is the string. If I print it, it will print all three different data types in a list. So it contains a string, integer, and a floating character, which is allowed in the list. And next one is creating and accessing list. Creating a list is very simple. We use square brackets and separate items using commas. We use square brackets and separate the items by using the commas. So in this example, you can see I have used in square brackets and separate three different data types by using the commas. So to initialize an empty list, we just use square brackets itself and we not perform any operations in that. So an empty list simply means the list has no items. Next one, accessing items with indexing. Every item in a list has a position called an index. Python starts counting from 0, not 1. Python starts counting from 0 but not 1. For example, here we are having apple 101 and 1.25. So index values are like this. Apple is at index 0. 101 is at index 1. 1.25 is at index 2. Okay, if we write, for example, if I write print of fruits of index 2, then it will print only that particular index value. Here you can see 1.25 because 1.25 is at index 2. So Python always starts indexing from 0. Remember this. Next, negative indexing. Python. So sometimes we want to access items from the end. Python allows negative indexing. For example, in the above example, I have written that print of fruits of 2, which will print 1.25. Instead, for getting the value of the last element, we can also write like this. Print of fruits of -1, which will get the last element in the list. So the output is the same, 1.25. This is called negative indexing. So in the negative indexing, if we try to access an index that does not exist, Python throws an error, which is an index error. For example, if I write Python fruits of -5, it will shows an error. See, it is showing index error, list index out of range. Okay, and next one, indexing and slicing. So sometimes we don't want the entire list. We only need a few items. This is called slicing. The syntax is the syntax for the slicing is, I'll show you, list of start colon stop. This is the syntax for the slicing. The start index is included, but the stop index is not included. For example, if we are having a list like numbers equal to 0, 1, 2, 3, 4, 5. So if I write print of numbers of 2 colon 5, so it will print the output like 2, 3, 4. So this is the output. Here start is included and stop is excluded. So index 5 is not included. This is called indexing and slicing. The next step is slicing. So we can also skip elements. So this is just like the range function we already thought in the looping concepts. This is just like the same, but here we called as indexing. So here step in slicing. Step in slicing means we can also skip some elements, right? For example, 1 colon at 5. It will print 1 because it takes steps. Here the output is 1 because the last value is 5, means it moves 5 positions every time. It moves 5 positions every time. If we keep 2, it will move 2 positions every time. So it will start at index 1, it move 2 positions every time. So it will next print 3 and next 5. This is called step. Next, reverse a list. How to reverse a list? We are having the above list. We want to print 5, 4, 3, 2, 1, 0. How should we do that? So for that we just use negative indexing. By using the negative indexing we can print the last element, right? We can do this like print of numbers of colon colon minus 1. So this is a shortcut to reverse the list. Remember, slicing creates a new list. It does not change the original list. Slicing will create a new list. It does not create the original list. Next one. List methods. So Python provides many built-in methods to work with list. Let's see the important ones. So first one is append. Adds one item at the end. Append will add one item at the end. For example, here we are having a list called fruits. In that we are having apple and mango. So if we want to add one more element in the above list, we should add by using the append command like this. Fruits dot append of banana. So it will append the banana in the above list and we should print it to get the output. So you can see apple, mango and banana. This is the output. And next command is insert command. Adds an item at a specific position. The insert command is used to add an item at a specific position. For example, fruits dot insert of 1 comma orange. So here we are adding orange at an index of 1, which means in the place of mango we are replacing mango with orange. Insert of 1, for example 3. Okay, here we are not printing it, right? Print of fruits. So you can see the output apple, orange, mango and banana. In the place of mango, we are replace it as orange and the mango has moved to the next index. Next one is extend. Adds multiple items at once. Extend. So the syntax for the extend is fruits dot extend of values. Here I have taken grape comma kiwi and then I'll print it to show you the output. So here the output is grape comma kiwi. It has added at the end. And next, remove. The remove function will remove the first matching value in the list. The remove function will remove the first matching element in the list. See, the mango, we have removed the mango from the list. Next one is pop. The pop removes an item using its index. Pop will remove an item using its index. For example, here I have written fruits.pop of 2, which will pop the element which is at the index of 2. So here in the second index, we have banana. You can see in the above output, we have banana at the second index. So, and in the last output, we don't have banana, which means we have removed it by using the pop function. And next one is clear. The clear will delete all items from the list. If we want to clear the entire list, we just want to write clear to make it empty. Now list will become empty. So you can see in the braces we don't find any value. And index. Next one is index. Returns the position of an item. The index will returns the position of an item. For example, I'll take another list like numbers equal to. Now numbers dot index 3 it will print 2 because in the index 3 we are having 2. And next one is count. Counts how many times a value appears. It counts how many times a value appears. Its syntax is numbers dot count of 2. Next I'll print it. So the 2 is appeared only one time in the above list. So its count is 1. And we also have some operators in list. So for example, in operator, it checks whether an item exists in the list or not, and sorts the list in ascending order. Reverse, it reverses the current order, and sorted returns a new sorted list without changing the original list. So you guys can practice this by yourself. And we also have copy. It creates an independent copy of the particular list. It creates a copy of that particular list. Next one is looping through list. So lists are iteratable. Lists are iteratable. So we can use loops to access every element. For example, the basic loop is for fruit in fruits, print fruits. So for this, we first want a list that should contain an elements fruits. So it will print one by one. The loop prints each fruit one by one. Next one, enumerate. So sometimes we need both index and value. We also covered this concept in the previous session. Enumerate, it will print both index and value at the same time. By using the enumerate function, you can go through that video if you want to check it out. And next one is range of length of list. So if we need to modify the list using indexes, we can use for loop. We can use for loop. For example, I'll modify it for I in range of length of fruits. So this is useful when updating list values. So it will also gives the same output as above, but here we are accessing each element in the list by using the range function by instead of directly by for fruit in fruit, we are accessing each element by using the range function. Now nested lists. A list can contain another list. A list can contain another list. For example, matrix. I'll take an example of matrix. Matrix equal to list of 1 comma 2 comma another list of 3 comma 4 another list of 5 comma 6. So this is the matrix. So to access every value, we use nested loops. These nested loops concepts we have covered in the looping class. So you can go through that particular video to know the looping concept. So one loop goes through each row. The second loop goes through each value. So it will print the final output as like this only. Okay, so one important tip is do not add or remove items while looping through the same list. It may skip elements or produce unexpected results. Next one, list comprehension. List comprehension is a shorter way to create a new list using a single line of code. The general syntax is new list equal to expression for item in iteratable if condition. It is simply a shorter version of a for loop. It is simply a shorter version of a for loop. Basic comprehension. Squares is equal to x into x for x in range of 1 comma 6. It will print squares. So with condition. For example, I want to print all even numbers. Even equal to n for n in numbers if n percentile 2 double equal to 0. For these, we first want numbers. N. Okay. Next one is print of even. It will print all even numbers. So here it is just like the for loop, but in only one line we have written for loop and we have checked the condition, which means we have used an if block also. So this is known as list comprehension. In the list comprehension, we can write loops and conditions in only one single line for avoiding multiple lines, for avoiding space complexity too. And next one, if else. Next one is if else labels. Next one is if else labels. Even. So it will print even if n percentile 2 double equal to 0. Else it will print odd for n in numbers. So for this, we first want numbers. You can see odd, even, odd, even, odd. Because 1 is odd, it will print odd. 2 is even, it is printing even. So this is the use of labels in Python. In strings, sorry. If else, yes, we have covered. Next one is string example. So for this, I'm taking a list called letters equal to. So here in this, the string example, we have covered the entire A to Z letters in the upper word by using the upper function. So this is another example of the strings converting lowercase to the uppercase. So this is the summary of the above session. You can go through this. Next one is the common mistakes. So let's discuss some common mistakes that the beginner will do. Mistake 1 is copy versus reference. Writing b equal to a does not create a new list. So both variables refer to the same list. Instead, use copy function like b equal to a dot copy instead. See, confusing copy with reference. Use copy function. Next one is slicing. Remember, the stop index is never included. In the list 0 colon 3 on a 3 item, the third element will not be included. Instead, it will be excluded. Remember that. Next one is modifying while looping. Avoid adding or removing items while iterating through the same list. Instead, loop over a copy if needed. Loop over a copy if needed. And then index error. If you try to access an index that does not exist, it will throw an error which is an index error. See, the error should be like this. So today we learn what lists are and why they are useful. We saw how to create list, access elements using indexing, and use slicing to get part of a list, and applying common list methods, looping through list, create new list using list comprehensions, and avoiding some common mistakes. So lists are one of the most frequently used data types in Python. So practice these concepts regularly by writing small programs like a shopping list, student marks, or to-do list. With regular practice, working with list will become easy and natural. So thank you everyone. In the next class, we'll continue with more Python concepts. Bye.